presentation because also last week I forgot to make eye contact with people I was presenting for. And my second learning goal is to control my nervousness. My presentation is going about Daisy World. And Daisy World is an imaginary planet which has been used to simulate the effect of vegetation on the global temperatures. First I would like to start with this picture. It's called Blue Marble and it's one of the most spread pictures in the world, it's sad. It is made, you can see the planet from here totally enlightened by the sun, and for climatological scientists it has been of great influence, since this kind of picture showed to the people that we have to see the Earth as a very big ecological system. And James Lovelock, he had a hypothesis about this, and that's the Gaia hypothesis. And this hypothesis states that life itself is responsible for maintaining the climate that light itself needed. So life regulates ocean salinity, oxygen content, the global surface temperature, and the carbon cycle, and therefore it regulates life itself. And that's a very beautiful theory, I think. And the Daisy World simulation is a simulation to find out how the vegetation or life on Earth regulates the global surface temperature, and it is based on a imaginary planet. So there is no planet called Daisy World, but just suppose there was a planet, and this imaginary planet has only one big ball of black soil. But there is life, and only one type of species, and that are white daisies. And the main question of Daisy World is, what is the influence of surface temperature on the daisies, and how do the daisies influence the surface temperature on the planet? So what are the effects to both ways? The effect of temperature on daisies is a very simple graph with a top. You have a minimum temperature and a maximum temperature, because when it's freezing the daisies can't grow, and when it's very hot the daisies just burn in the sun. And between these two minimum and maximum temperature there's an optimum in which you will find the greatest daisy coverage on Daisy World. And so that concludes the influence on temperature on the growth of daisies. But the daisies itself also have an effect on the temperature on the planet. And that effect is called the albedo effect. The albedo effect is the effect of the Earth's surface and causes the incoming energy, which is coming from the sun, to be reflected. If you have a very wide surface, most of this energy is just reflected back into the surface, and this energy is not taken up by the atmosphere or the planet's temperature. And if you have a dark surface, most is absorbed. Just in case of Daisy World, the dark soil absorb lots of energy, so cause heating of the planet, while the daisies, which are white, reflect most of the energy coming from the sun, and therefore cause a cooling effect. This cooling effect you can see in this graph. It's very simple. You have the daisy coverage, and here the average surface temperature, and the higher the daisy coverage, the more sunlight is reflected, and the lower the average surface temperature will be. And now we have here a graph with daisy coverage and average surface temperature, showing the effect of daisies on temperature. In the previous slide we had also average surface temperature and daisy coverage, and we can combine these two graphs, and yeah, here you can see it again. And this graph shows two equilibrium states. So in case of Daisy World, you will get two states in which you have where the influence of temperature on daisy coverage, this has the same. This is the influence of daisy coverage on temperature are the same, and these are the only two states of daisy coverage and temperature that can occur on this planet following this reason of thinking. And That is called equilibriums, and you can see when a little perturbation happens, for instance when the daisy coverage just grows from no reason, you will find that, look from here to here, it will go back to the equilibrium state because it doesn't suffice to the effect of temperature on daisies, and therefore you only have two equilibrium states, one stable and one unstable. This assumes that the incoming solar radiation is constant, but that isn't the way, and that is because of the Milankovitch cycles. The Milankovitch cycles are very difficult. It's just like the Earth is wobbling around the Sun, and therefore sometimes there's more solar radiation coming in, and sometimes there's less. And here you can see how that propagates through time. So we receive different kinds of solar radiation, so more warm or less warm. And what would happen if you have this in case of daisy world? It will have an effect of the daisy coverage, and the surface temperature will just change by changing this line, will just shift upwards if you have an increasing incoming radiation. And the line will shift downward if you have a decreasing incoming radiation. And what will happen in the overall graph, you will see that the equilibriums will shift. But this is very important because this makes that the equilibriums become less stable than in the previous case. And that is the main problem of this case. But what you will find is that in normal case this would be the increase of temperature if the solar radiation would increase. But in this case, the increase in temperature is just this bit. So it is smaller because of light itself, in case there weren't growing any daisies. And this is the result. The experiment done by Lovelock has been that he increased the solar luminosity, and he looked at what will happen to the temperature if you grow white daisies on the planet. And what he found out was that first the temperature increased by the solar luminosity, then the white daisies began to grow, and you had a very, very stable temperature until a certain point on which the equilibrium states are overtopped, and then all the daisies disappeared and the temperature just went up. But between these stages where the white daisies could grow, you can see that the temperature is quite stable. And that is the main take-home message of my presentation. And that is that the real world is similar to daisy world. Temperatures have been within a respectable range for over 3 billion years, and that is because of the vegetation growing on this world. If it wouldn't be the case, temperature would be much more fluctuating over time. But you also have to be aware that these systems have thresholds, which means that once these thresholds are overtopped, everything disappears and you live on a dead planet. Thank you for your attention.